Unit 4, Lesson 8, Sine and Cosine in the same right triangle. So we're going to start off with our exercise 8.1. I believe that's the warm up. Which one doesn't belong? Four triangles. 5 minutes. Okay. Let's see. So which one doesn't belong? Let's take a look. Let me zoom out so we can see all four at the same time. All right. So go ahead and pause the video and try to figure out which one doesn't belong? And that's a pretty open-ended question, so don't be surprised if you have multiple answers. Okay, so hopefully you pause the video, and this is the first time I'm looking at it. So what do I notice? Let me look. Let me start with the angles, right? Like we know that you have the right triangle here, so that's 90. Therefore, this missing angle here has to be 20, right? Because triangle sum theorem. Same thing here, except it's the other way around, right? So those angles, so these two triangles appear to be um, similar, right? Like a triangle A and triangle B are similar. Their angles are all congruent. um, we can't really say the same thing definitively about triangle D. Triangle C is very different in terms of not being a right triangle. Like like you got right triangles, right? For here. So my educated guess, I would go ahead and say C, only because it's not a right triangle, right? But could there be other reasons for a certain triangle not to belong? Yeah, I mean we got sides, we got variables, right? You can even make an argument that you know triangle B doesn't belong because it has a variable y, while all the other triangles have a variable x. So you can make all kinds of reasons why. Certain sides were not given, right? So you can make a vast array of arguments. Notice the relationship, right? Like between the 70 and the 20. Like I was like, oh, the 20 is missing, but in the other one, the 20 was given, and I could still realize that, oh well, based upon the pairing, those two angles definitely have to add up to 90 degrees. So notice that idea, right? Okay, so let's get to the meat and potatoes for this lesson. Exercise 8.3. It says explain the connection. Um, it's a good play on words. Draw a diagram that will help you explain while sine of theta is the same or equal to cosine of 90 minus theta. Well, sure. Sure. Let me draw you that right triangle. Remember we had that 70 degrees and 20 degrees situation? So let me see. Let's make sure that we uh, don't go too off the reservation in my explanation. I don't want to uh, trip anyone out. Okay, so sine of theta. Let's go ahead and label this triangle. We got A, we got B, and C, right? Okay. And hypotenuse, and we'll label this X for the base, and for the height, we'll do Y, or the leg will be Y. Okay. Sine of theta. Let's say my reference angle is here, angle A, theta. Okay. Um, if theta was 20 degrees, we know that angle B would have to be 70, right? So whatever theta is, angle B is really just the remainder out of that 90 degrees. So 90 minus whatever theta is, right? Everybody agrees with that? So if I did sine of theta, right? Sine of theta, which is angle A, right? The measure for angle A. Sine is opposite over hypotenuse. So that'll just be y over the hypotenuse. Great, great. Now they're saying cosine of 90 minus theta. Well, cosine of 90 minus 90 degrees minus theta, cosine is adjacent, right? So adjacent over hypotenuse. The adjacent for cosine of 90 minus theta, right? Now your reference angle's here, right? So your adjacent is y. Your hypotenuse is still h. But notice those two ratios, those trigonomic ratios, are the same, right? So that would be a great way of explaining why sine of theta is equal to cosine of 90 minus theta. So notice that, okay? For example, let me give you another triangle, this time with actual values. Let's go ahead and do that that 20 degrees, 70 degrees bit, right? Like this is 70 degrees, this angle here is 20 degrees. Okay, so sine of 20 degrees, right, should be the same, right, as cosine of 90 minus whatever theta is, and theta is 20. I'm just substituting in, right, the degree. So instead of 90 minus theta, I'm doing 90 minus the 20 that was given, right? So sine of 20 degrees is going to give you the same ratio as cosine of 70 degrees. Okay, so that's what they're really going at. There's a relationship there. Okay, and that's why like I said, there was a play on words, connection, right? Because they really are coexisting between 90 degrees. All right, all right. So the lesson synthesis, and this is a pretty quick lesson. Um, they are saying um, three things here. They're saying sine of theta is less than cosine of theta. And they're saying find the values of where that would be true. In this situation, they say if theta is less than 45 degrees. So if you have 44 degrees, right, for theta, um, then you have to be 46 degrees here, right? So, for example, sine of 44 degrees is going to be less than cosine of 44 degrees. Okay. And you can already see the angle because the angle is larger, right? Um, if theta is exactly 45 degrees, right, like here and here, the two ratios will be the same. Okay, the two ratios, whatever the measurements are, the ratios will still be the same. Okay, and that's because your sides here, like this leg and this base, will be the same length. So if they're divided by the same hypotenuse, they're going to be the same. Okay. Now, if your theta, if your measure is greater than 45 degrees, okay, sine of theta will be greater. A great example of that is like 70 degrees for theta here. Well, your other angle here has to be 20 degrees. All right. So your ratio is going to be much larger for sine of theta in this situation. Okay, and that's because again the leg here is a lot larger than the base, right? So the leg divided by the hypotenuse is definitely going to be greater than the base over the hypotenuse. Okay. All right, that's the end of the lesson. Have a beautiful day.